Hi, my name is Aditya. I'm president at Corridor Platforms. Today, I'm going to talk about risk management or novel risk management for LLM pipelines, an approach that is driven off the expertise that we carry in this area. And we recently launched a product for as a starter validation kit for LLM pipelines called GenGuard X or GGX. So a lot of the stuff that I'm going to talk about are coming from our live experiences of building the solution specifically focused towards regulated verticals like banking and healthcare. All right, before we jump into the risk management aspect, there are certain elements of the AI to GAI that inherently make GAI more risky and create novel risk. Novel as in something that is unique and we haven't seen in the AI journey. First, when you look at the AI journey, remember that you had data that you controlled. It was your data sets. The ML algorithms were algorithms that were trained over time. They were mature. We understood how they were built. We understood how to interpret them. And then the solution that you got was with basically controlled data, controlled algorithms gives you relatively controlled solutions. Even the deep neural nets, we had a pretty good understanding of them, as we advanced on the edge of the AI to GAI. When you get into the GAI journey, here's what happens. The data sets that are used to train the foundational models, well, those are, large data sets like the C4 data set, which is not in your control. You do not know what the model is training on, even though the foundational model providers, for example, like Anthropic, are taking a lot of trouble to make sure the data sets are clean, do not control, do not have biases, do not have toxicity, are chosen from right sources. But end of the day, they are controlling, not you. The transformer architecture itself is highly complex. That's the second part. And thirdly, you're bringing in your fine tuning data sets or your fine tuning approach to essentially limit or harness the power of a GAI or a LLM towards the solution that you're creating. Inherently, therefore, the GAI pipelines are more risky. Great. So now that we understand that, let's jump into, well, what should I do? The regulators have been thinking about this quite a bit, and especially since these are critical AI systems as defined by the EU AI Act. Anything that's got to do with lending, etc., lending or customer management activities which involve financial aspects are considered critical AI systems because they affect the lives of human beings. Now, the way the regulators are approaching it is twofold. Firstly, they're looking at what can I lift and shift from an AI to a GAI. So there have been existing set of regulatory compliances, for example, model soundness and fairness, fair lending bias, quality of data sets used, the modeling processes that has been followed through. These have been existing guidelines that have been followed. And what the regulator is saying, let's bring those over to the GAI. And then there are certain unique aspects. There's a lot of input output testing or boundary testing. So let's augment that, the initial AI regulatory framework, let's augment that for the GAI. But in addition, the AI acts that are emerging, including the EU AI Act, are starting to look at how these LLMs are built. So they're very particular now. Well, what is the data sets you're using? What is your documentation? How do you maintain control, version control on your data sets? They want to see data authorship. They want to see, is the process transparent to users in the way these models are being built? Is there a comprehensive risk management framework that looks at every component of the LLM pipeline and controls it for risks like toxicity and biases, right? So they are essentially saying, we want to see how the sausage is built, not just look at the outcomes. Remember, earlier regulations were very focused on the outcomes. Given this, now when you look at an overall LLM pipeline, broadly, you have, that's the top part, you have the foundational models that you use, which will have some pre-training data. And then you have a fine-tuning approach where you are either using label data sets and you're fine-tuning, or you're using RAGs, and or you're using prompt engineering approaches, or you're additively doing all those three. Now, every component of these pipeline during the build in the blue boxes, just think of it like a little bit high level, there is a control measure in place. So when you're using prompt libraries, are you want to authorize those prompt library data sets and make sure that the prompts deliver the outcome that you wish to get. And in sense, the regulators are saying, as a risk management framework, you need to have an authorized set of prompts that you can use for a set of use cases. On the other hand, let's take another example of RAG. So what the regulator is saying, do you have an optimal best practice approach in the way the RAG is structured, in the way the embedding models are being used, in the way the vector search is being done on them? Similarly, on the label data sets, what is the quality of this label data set? Are you labeling high quality, knowing this is an NLP kind of scenario, right? So they're starting to look at every one of those components and make a decision on what level of risk that you carry. And then when the model is approved essentially and goes into a validation, or when the model is ready from a validation perspective, then you have a set of, let's just call it pre-prod UAT related assessments that you need to do, and there's a rigor that has to go through where you're testing the entire pipeline end to end. Finally, when you deploy it, you want to have guardrails put into place so that not only are you monitoring for abnormal behavior, but you also have a human in the loop. And this is being mandated by the regulators. Let's get a human in the loop to make sure that these LLM pipelines are not hallucinating. And you need to have a feedback loop back to training the model from production, and the human in the loop evaluation whether these LLM pipelines are performing. So human assist in LLM driven architectures to solve use cases is something that the regulators are mandating, saying that they're not comfortable AI or GAI in this case just directly going into production. There needs to have a human overlay. But this is the overall framework in which you would operate. I'm going to give finally one example of something that we did on the platform to look specifically at, let's say, a fine-tuned model, its biases, implicit biases that we carry. So it's a very interesting example. What we said was, let's use occupation as as a proxy for bias. So what we give it is gender, age, and education qualification of that particular person, and then we ask it to basically predict what could be the kind of job this person could have. So as an example, when there's a male, age is less than 21, and education profile is less than high school, it starts to predict a construction worker as the potential occupation. Essentially a medium income is, a construction worker. Essentially what it's saying, that it's skewing its responses to the male. So this is how you tease out potential biases in the model. And there's a lot more I could cover, but in a sense of time, I will not do that today. But when we applied these specifically designed proprietary tests, and you can see there's nuance here, when we applied these to the LLM pipelines, we saw that there were three models. I won't name the models for a reason, but model number two was showing much less of bias relative to model one and model three. And then we did this at every component of the LLM pipeline, just like I talked about in the framework. So hopefully that gives you a quick rapid fire assessment and a view of how regulators and organizations that care about this very deeply and in a regulated space, how they're approaching the initial forays into risk management. Risk management for LLM pipelines. Thank you.